So hi and welcome, my name is Craig Dunn and I'll be your instructor for this course. In this course we're going to look at Git, the version control system. I've been using Git now for well over 15 years and I use it in all of my projects, from small experimental things to larger collaborative open source projects that I maintain. And I can honestly say that I wouldn't get the level of productivity that I do if I didn't have tools like Git at my disposal. So in this course we're going to cover the basic concepts of Git, we're going to walk through all of the common commands that you need to use Git day to day, and we'll give you an understanding of the core principles behind version control itself. In this course we're not going to delve into the computer science side of it, we're going to lead with practical examples and explanations that are easy to comprehend and understand. Git is an incredibly powerful tool, and if you start digging around in some of the documentation, it can be a bit mind-blowing just the amount of features and things that it can do. So in this course we're going to look at some of the more essential concepts that you need as a beginner in order to start using Git in your project workflow today. We'll cover how to set up Git and configure it, and then create our very first Git repository. And then using that repository, we'll go over all of the steps that you need to add files and other content to that repository, to make modifications, to view the Git history. And then later on, we'll look at a few more advanced topics like branching and tagging and working with remote Git repositories. So please do join me for the rest of this course, and I really hope that you enjoy taking it as much as I've enjoyed making this content. I will always do my best to answer any questions or any queries that you have along the way, so please do get in touch, reach out to me if you need anything. So let's dive into the world of Git. So in this first short section, we're just going to look at how to install Git and do some basic configuration. So Git's available on pretty much all platforms, on Linux, on Windows, on Mac. I'm going to be using Linux throughout this course, but you can easily find out how to install on other platforms by going to git-scm.org. And there on Git's homepage you can find the download instructions for other platforms. So let's dive in now, install Git on our local machine here and do some very basic configuration to get us started. Git is available across most operating systems, on Mac, on Windows. I'm running on Linux, specifically Ubuntu. If you're running on Linux, then the package name is just Git. So on a Red Hat system, you would just yum install Git. I'm on Ubuntu, so I'm going to sudo apt install Git. And this will pull in the Git package and all of its dependencies. And I can check that with just typing the Git command with --help. And that's successfully installed. There's very little configuration you need to do when you first install Git, but there are two important things, and that's to set your name and your email address, and these are used in the Git history, in the log messages. So to do that's quite simple. From the command line we just type git space config and then --global, and the first key that we want to set is our name. So the key is user.name and then the value that we want to give. So within quotes, I'm going to give my own name, Craig Dunn. And then the second thing we want to configure is the email address. So again, git config --global user.email and then the value, which will be my email address. And in order to get started using Git, they're really the only two things that we need to configure. So now we've done that, we're good to create our first repository. So now we've got Git installed and configured. In this section we're going to look at creating our very first Git repository, which is a lot easier than you might think. And once we've created our repository, we're going to look at how we manage files within that. So creating a Git repository is pretty simple. We start off with a folder for our new project. So let's just make a directory called my project. And once we've got this empty workspace, we can convert this into a Git repository by just using the git init command. So right now I have an empty directory, and if I just type git space init, that will now convert this folder into a empty Git repository. And if I do another ls here, I see it's created this directory called .git. So the .git directory is what Git uses internally, and it's how it maintains the status and the history and the revisions within your Git repository. And here the first Git command we'll now look at is the git status command. So if I type git status at any time, it will give me information as to the current working status of my Git repository. And I see here that I have a valid repository, there are no commits. So it really is that easy to install and configure and then create our first repository using Git. So now let's have a look at the three main phases of making a change or adding content to a Git repository. So we start with files that live in our working directory here. And this is what we see on the file system in our project root. So firstly, we make changes to these files and we save them within the working directory. The first stage of adding these into Git would be to stage them. And we use the staging area to collect up all of the changes that we want to make in a particular transaction into the Git repository. And then the final step, when we're happy with the changes that we have staged, is to commit those changes. And when we commit those changes, they become part of the project's Git timeline, part of the history. So let's now have a practical look at how to create our first file and commit it into our Git repository. So what we're going to do now is we're going to add our first file to this new Git repository that we've created. And in doing so, we'll look at how we take local changes and then stage those and then commit those into the Git repository. So let's start with creating a README file in the root of our project here. So I'm just going to edit a file called readme.txt. I like to use Vim, but you could use whatever editor you want. And give it some content. And then we save that file and come out of the editor. So now I have a file called readme.txt in the root of my project. Now what happens now when I type git status, here I can see that Git has picked up on the fact that there is a new file in this directory. So here we have changes in our local workspace. The first thing we need to do is submit those changes to be staged. And then once we finish staging all of the changes that we want to make, the final step is to commit those, and once they're committed, they're in the Git repository. So the change here is the addition of a new file, and the way we can stage this for commit is to use the git add command. So we use git add, and then followed by the name of the file name that we want to add. And now let's try typing git status again. So now we see that git status tells us that there is a new file called readme.txt. It's not saying it's untracked. So this is a stage change that we can then later on go and commit into the repository. Before we do that, and just to explore this point, let's make another change to the readme.txt file. And I'm just going to add in some extra text of hello world and then save and come out of that file. So now I'm going to run git status again, and let's see what that says now. So git status. So now I have two changes that Git is aware of. I've got my initial change, which was the addition of the readme.txt file, so creating a new file, and that is a change that we staged for commit, so that's showing up here. But what Git's now discovered is that there's a difference between what is staged for commit and what we've got in our working directory. So it's saying that we have two changes. One is this new file, and the other change, which is currently not staged for commit, is a modification to that file. So currently we have, within the Git repository, we currently have no content, we have no files. In our staging area, we have a new file called readme.txt with that initial text that we put in it. And then in our working area, we have the addition of another modification to the readme.txt. So I'm able to use a command called git diff. And with git diff, I can actually view what the changes are between what's in Git and what's in my local working copy. So I can do a git diff and then the name of the file. It's showing me the difference between what I have in my working copy here and what Git has internally. And the addition here is the new line and the hello world that I just added. So again, I can go ahead and stage that modification for commit as well by using git add again. And then now if I look at git status once more, I can see now that I don't have any unstaged changes, that both the creation of the readme.txt file and the modification that I've made to it are both in the staging area. They've both been staged to commit. So typically what we'll do when working with Git is that we'll make changes, we will submit those changes to be staged, and then once we're happy with all of the changes that we want to make, the next step is to then commit those changes from the staging area into Git itself. To commit these stage changes into Git, we use the git commit command. And if I just type git commit, it will then throw me into a text editor. By default, it's probably Vim, but if you use another editor like Emacs, then just by setting your editor variable in your environments, you can control which editor will get loaded. And I'll show you later a command line trick where you can avoid having to use an editor altogether. So the reason we get thrown into an editor is that whenever we make a commit in Git, so whenever we make a change to the Git repository, we're able to give what's called a commit message. And that commit message is basically arbitrary text where we can describe what our change is, why we've made it, to basically make it easier for people reading the Git history in the future to understand this change that we've made. So when writing commit messages, it's important to try and be as clear as possible to explain the reasons for your changes, understand that somebody might be looking at this change months or 6 months or years down the line and might want to know what the reasoning behind this was. And think back to when you've looked at your own code like a year later after you've written it and you haven't put comments in and you haven't provided any documentation and you've completely forgotten why you made a particular change. By using Git commit messages, we can avoid that and we can always have a history of what was changed and why and by who. So here I'm going to add my commit message. So all of the lines here that begin with a hash, the comment lines, they won't appear inside your commit message. So for now, let's just look at this bottom bit. We can see that the changes that we're committing right now is this new file called readme.txt. So once I've written my commit message, I can save and quit out of the editor. And as soon as I quit out of the editor, then my commit has taken place. So my readme.txt file has been committed into the Git repository. And what I can now do is run git status again. And the two important things here to note are there is nothing in the staging area waiting to be committed, and my working tree, so the folder that I'm working from, is clean. So by clean, that means it's in sync with what Git has in the repository. So now we've seen how we can commit a new file into the Git repository. Let's take a quick look at directories. So directories in Git can behave a little bit strangely, and I'll walk you through that now. So let's say we're back in our working tree here, and I just create a new folder called HTML. If I try and now add this folder to the Git repository, I'm going to follow the same steps as we would have done for a file. First, I'm going to go git status. By running git status, I would have expected it to show up telling me that there's a difference between my working tree and what's in Git, and that difference is the creation of this HTML directory. But one thing to realize with Git is that it has no concept of dealing with empty directories. There is no way of committing an empty directory into a Git repository. If you need to have an empty directory in Git in order to deploy, the only way you can really do it is by placing some kind of a placeholder file in there. So right now when I run git status, it's not showing any changes. If I create within my HTML directory a new file, so now when I run git status, it is showing me that there's a difference between my working copy and the Git server. And it's telling me I have an untracked file called HTML. And now I can use the git add command to add that to the staging area. So let's do that now. And then run git status again. So here we notice that by running a git add and then giving it just the HTML directory name as an argument, has staged the file within the HTML directory, so it's staged the HTML index.html file as a new file. So this is something important to realize when dealing with git add, that you can give it a specific file to add to stage into the staging area, or if you give it a directory name, then it will take any untracked changes within that directory and any subdirectories of that, and it will automatically stage them for commit. So let's demonstrate that now by creating a few more files in the HTML folder. So here within my HTML folder, I've created 3 new files called about, contact, and help.html. And I'm going to go back to the root of my project folder. Now what happens when I type git status now, we have the new file index.html that we staged earlier, but we're now seeing these 3 extra files that are currently untracked and not staged. So what we could do is go through each one of these and git add html/about.html and contact and help. But as we just talked about, if we give a directory name as the argument to git add, then any untracked changes down that directory tree will automatically get staged. So we can just go git add html again. And now if we run git status again, we can see we have 4 new files staged for commit. We have our original index.html and the 3 new files that we created. So in order for these changes to get added to the repository, we of course need to commit these as we did before. So I can just type git commit. And if you don't want to get thrown into a text editor like we saw before, then there is a shortcut on the command line I told you I'd share with you, and that is the -m flag. So the -m flag will set the git commit message, and then within quotes I can just give that on the command line, and this saves having to go into an editing session. So here I can get a meaningful message of that. And now we can see that Git has committed all 4 of those files into the Git repository, and if I type git status again, then I'm showing a clean working tree and nothing staged to commit. So we've looked at adding new content into the Git repository. Let's look now at making modifications to existing files. So I'm going to modify my help.html here and add some more content. And again, let's do a git status. Now here we can see that what I have in my working area differs from what's in Git. So Git's detected that we have a modified file called help.html. Again, I can use git diff to see what those changes are. If I do a git diff with no arguments, then it will show me all of the changes between what I've got in my working copy now and what's in Git. And I can see that the only change here is of help.html and adding these lines. When we're modifying files, we still need to stage the changes and then go on to commit them. But when we're dealing with modifications to files, we're able to do both of these things in one step. So rather than doing the git add and then the help.html, which would add it to the staging area and then going on to do a git commit, we can straight away go to git commit. We can use -m to give it a commit message. And then importantly here, we can use the -a flag to commit. So by adding -a will basically tell Git that anything that we've modified, we're going to assume that we want that staged and then perform the commit. So I can do both of those steps in one command. And here I can show that if I type git status again, we now have a clean working copy. So we've looked at adding and modifying files. Let's just cover a couple of other points quickly. Firstly, to move or rename files within a Git repository. So if I come down here into my HTML directory, if I want to rename a file in a Linux system, I would typically use the mv command. So mv, the file name, and the new name. That won't work in Git because Git won't have any knowledge of that transaction. But in order to rename a file in Git, it's almost the same as doing it on Linux. We just do it via the git command. So instead of mv, we use git mv, and then the name of the file that we want to rename, and then the destination file name. And now if I look at what I've got in my working copy here, I can see that it has moved it on disk as well. And if I type git status, we can see that Git is aware of this rename, and it is a change that's been staged for commit to rename help.html to support.html. So I can go ahead and commit that change. With the -a flag. Actually, I didn't need the -a flag there because it was already staged. So that's how we rename a file. The last step now would be, how do we remove a file from the Git repository? And again, this is very, very similar to how we rename. So within Linux, we would use mv to rename a file, but we use git mv within Git. The same is for removing a file, where we'd normally use rm in a Linux environment. We just do this through the git command. So we use the git rm command. So let's do that now. Let's say I git rm support.html. So we can see now that on our local working copy here, that we don't have a support.html. And if I do a git status again, I can see that I have the change to delete support.html staged for commit. But this time I'm not going to commit it. So once things are in the staging area, you can still revert back, you can still undo that change if you don't want it to make it to the repo. So in this case, I've decided that this was done in error and I don't want to delete support.html. So I can see here that it's got a helpful hint at the top here that if I want to unstage, so remove this change from the staging area, I can use this git reset head and then file name. Now we're going to talk a bit in the next section about the significance of what this head is. But for now, let's just go with what we see here on the screen. So I can now go git reset head and then support.html, and this will tell Git that the change that I currently have in the staging area for this file, I want to unstage that. And now if I type git status again, we can see that there are no changes staged for commit, but we can see that there are untracked changes that aren't staged for commit, and that's the deletion of support.html. And that's because when we initially did the git rm, the file was removed from our working copy, and that change was then staged to go into commit. When we unstaged it, we removed that change from the staging area, but that didn't revert the changes that had been made to our current working copy. So all we've really done is unstage that change. We haven't really got rid of it and reverted everything yet. And I can see here, if I look at what's in my current working copy, there is no support.html. So I've got two options here. I could use git rm again in order to restage the same change back into the staging area to commit it. Or if I want to continue with backing out of this change, I can take this command here, which is git checkout, followed by 2 dashes in the file name. And what this will do is check out the file from the Git repository, the last known updated up-to-date version, and place it in our working area. So let's do that. So I go git checkout -- and then the file name. If I do an ls, Git has pulled out the most up-to-date copy from what it has in the repo, which I can see here. And if I run git status now, we can see that everything is clean and there is nothing staged to commit. So there we've covered how to modify files, both their content and by renaming them and deleting them, and how we can stage changes to be committed, but before committing them we can unstage those, we can back them out, we can clean everything up. So traditionally when we're dealing with files on a server, we'll create a file, we'll save it to disk, and then when we make a modification to that file, we'll edit it and then save the changes, and when we save those changes, we're overwriting the file. So with Git and other version control, that's not the case. We never actually overwrite the file. We just keep a constant track of the changes that are made to that file. And the way Git does this is it provides us with a sort of timeline. So starting with the very first commit where we created the file, subsequently every time that we update that file or make any changes to it, these changes get recorded along Git's timeline. And just like a very advanced undo feature, we can always go back in that timeline to a particular point and pull out that file in the exact state it was. So we can think of a Git timeline as something like this. we create a file, and this is the beginning of time. At the other end of the scale, we have the present day, so this is how the file looks now. But we haven't kept multiple copies of this file. What we've done is since day one, every time we've made a change to that file, we've recorded what that change is on the timeline. And every time we make one of these changes, Git generates what's called a hash, which is a unique identifier for that change. So by not overwriting the file, and by just recording the iterative changes, we have the ultimate undo. We can go back in time to any particular point and see exactly how that file looked then. So let's have a quick look at how we can use Git to look at the timeline of our project. So if we want to take a look at the Git timeline, the Git history, we can use the git log command. And I can do that with just typing git log from within my project directory. So starting with the most recent commit at the top here, I can see the author of the commit, so the name and the email address of who made this commit. And these values come from what we configured when we first installed Git. So the user.name and user.email. And we can see the commit message that we added when we committed the change. So the other thing you'll notice here is for each commit we have this string of digits, and this is known as the hash. So as we discussed before, this is the reference that Git uses within its timeline. So every time we make a commit, the timeline is updated with those changes, and that's associated with a unique hash. So we can always use this hash as a reference to go back in time to any point within the history of our Git repository. There's also a useful flag to the git log command, which is -p, and -p will show us the patch diff for the commits. And I can also give an argument to git log of the commit hash, and that will cause the log to jump to that point in the history. So here I can take, for example, this commit here. If I want to see exactly what this commit was and what was changed, I can do a git log, and I can use -p, and then I can set it just to jump to this point in the timeline. So it'll jump to this point and give me a patch diff of what the change was. And there we go, I can see the same information as before, but I also get this useful diff now, and I can see that within this change that we added this email address. So we've looked at this concept of a Git timeline or a Git history. And along that timeline, we have commits, and these commits contain the changes that we've made over time to the files in a repository. This timeline exists on what we call in Git a branch. And the branch has a beginning, where we made our first commit. And at various points throughout the branch, we have the commits that represent the changes to the repository over time. And then right at the front of the branch, so the most recent version, is what we call the head. So when we refer to the head in Git, we're talking about the front of the current branch. Every time we make a commit, the head of the Git branch will move up to the latest commit. When we initialize a Git repository for the first time, the default branch that gets created that we're actively working on is called master. So right now in our Git repository that we're working with, we're on a branch called master, and we're currently at the head position of that branch, and that's the content that we can see. So we've currently just been working with the one branch called master. What we can also do with Git is we can create new branches. When we're creating a new branch, that new branch is based off another branch. So we could, for example, on our master branch, create a new branch, a copy of the master branch that starts from the head of the current master. We can also go back in time across the timeline and create a Git branch from the master branch at a particular point in time. So developers will often use branches as a way to work on a feature set or a bug fix or another task independently of what's going on in the master branch. So it enables a developer to write code to test it in an isolated way that won't affect anything that's going on with the main code base. And then when we're ready, we can then integrate those changes back into the master branch and bring everything back up to sync. So there's two steps to this. There's first what we call the branching. So when we create a new branch, from this point forward, we work with this new branch exactly the same as we do with the master branch. So our new branch also has its own dedicated timeline. Once we've made changes in our new branch, we now have commits in this branch which don't exist in master, and at some point we're going to want to bring all these changes back and integrate this back into the master. And also the master branch will have changes and commits which don't exist in our new branch. So at some point we're going to want to sync all of this up, and to do that we use a process called merging. When we merge, we'll normally be merging back into the head of the master branch. So at this point now at the head, I have a combination of all of the changes that were made on the master branch and also the changes that we made when we created our new branch. So the way Git works is you can theoretically create a new branch that lives forever. This is not normally a good idea as it'll often get out of sync with your master branch. The way to use branches in a good practice workflow is to create branches that have a limited lifespan. They're only used to develop a particular feature set or a particular task or fix a particular bug. And then once that work has been done, it gets merged back into the master and then deleted. Branches that have significantly longer lifespans tend to get way out of sync and really hard to manage. So while branching is very powerful, it's important to understand what the use case is for branching. It's to allow developers to make changes for a particular task in an isolated way, but with the intention of pulling that back into the master branch. So when we run git status to see the status of our current repository, as well as telling us about changes that are to be staged and the state of our working directory, we also get to see which branch we're currently on. So now let's say that we want to add a new feature to this repository, and we're going to follow a sort of branching workflow. So we're going to create a new feature branch. We're going to do our work in that branch. That would enable us to collaborate, to develop, to test without affecting anything in our master branch. And then when we're ready, we want to merge those changes back into the master and back into the mainstream code. So firstly, if I type git branch within Git, it will show me a list of all of the branches that we have available, and it'll put an asterisk next to the active branch that I'm currently on. In order to switch between branches, we use the git checkout command. While we normally use git checkout to switch between existing branches, we can also use it to create a new branch. So git checkout, if I give this -b flag and then the name of a new branch, so let's call this new underscore feature. This is telling Git that I want to create a branch called new feature, and it's going to be based off the master branch, and it's going to be branching from the head of the master branch. So it will create that new branch for me and it will switch me into it. So if I now type git branch again, I can see that I have two branches available, master and new feature, and I can see the asterisk is next to new feature. So that's where I actively am right now. So within this new feature branch, I can play around here, I can add content, commit things to the repository, and nothing I do will have any effect on the master branch right now. So I can do that now. I go into my HTML, add a new file, so I've created a new file in my working area called product.html. I'm going to stage this and commit this as I did before. So first I'm going to add the new file to the staging area. And now I'm going to have a look at git status. And now I'm going to commit this change into the Git repository. So I'm going to use the -m flag to give the message on the command line. So I've committed that change, and if I run git status, I'm in a clean working tree. So I'm going to go back to the root here. So I can see now that under HTML, I currently have my product.html, which I've just committed. And let's just quickly look at my available branches again. So we said that we use git checkout to switch between branches, and it's basically as we did before, but without the -b flag. So if I now want to switch from my new feature branch back into the master branch, I can do that with git checkout followed by master. And now I'm operating in the master branch. Now don't forget, when we added the product.html file, we added that in the new feature branch. That's where we committed it. So now I've switched over to my master branch. If I have a look at what we have under our HTML directory, you'll notice we've got the 4 files that we previously added, but we don't have product.html. That's because that change currently exists on a branch of the master, so we haven't done anything to bring that code back into the master branch yet. So typically we'll be using Git branches in order to isolate a piece of work, so a bug fix, a new feature, and we want an area where we can develop it, we can test it, we can fix problems with it, and then once we've gone through whatever process that we go through in our development teams, then we need a way to take those changes and reintegrate them back into the master. And for that we use the git merge command. So I can see here that I'm currently on my master branch. If I want to know what the differences are between the new feature branch and the master branch, I can use git diff for that as well. So remember before we did a git diff on a file name, and that showed us the difference between what we have in our working copy and what we have in our staged area or what we have committed into Git. Git diff will also enable us to look at the differences between two branches. So here from my master branch, I can go git diff and then the name of the feature branch, which is new underscore feature. And this shows me the difference between the two branches. So in my master branch, this file and this content doesn't exist. So that's where we get the diff. I could do this the other way around as well. I could go into my new feature branch and then see the changes between new feature and the master branch by doing a git diff and master. So here we see the changes in the new feature branch compared to the master. So this effectively, once we merge the changes in, this is what's going to happen on our master branch. So we're going to create this file called product.html with this content. So let's flip back to the master branch using git checkout master. So if we're happy with all of the commits and all of the changes that we made in our feature branch, and we now want to pull all those changes in, reintegrate them into the master, we do that with git merge. So we just go git merge and then the name of the branch that we want to merge into master, which is new underscore feature. If I now have a look under HTML, we can see that we have this file called HTML product.html. So git merge took all the commits that we made in our feature branch and merged them, reintegrated them back into the master. So there are also times when we have a feature branch and maybe it's slightly long-lived, it could go on for even several weeks or even several months, and we're developing a feature in there, but there are changes happening in the master branch that aren't being reflected in our feature branch. And as time goes on, our feature branch can become very out of sync with what's in the master, and there might even be things in the master that we depend on in the feature branch. Let's do a quick example. I'm currently on the master branch and I'm going to add a new file here. And I'm going to add that description.html and we're going to commit this file. With git commit. So now if I look at git log, here what happened is we created the new feature branch and we branched that off from this point. And then after that point we merged changes back into this branch. But now we have a new commit here at the top, which is the adding of this description of the product, the change that we've just made. Now, because the feature branch was branched from this point, it won't receive any of the new additions to the master branch. So this commit won't exist in the feature branch, and we can validate that now. If I switch to my new feature branch using git checkout new underscore feature, we can see, of course, that the description.html is not here. And that's because if we look at the git log here, it was here where we did the initial branching from master, and then from that point, this branch has a life of its own, so it's not aware of what's going on in the other branches. So there may be times when we do need to keep our feature branches up to date with what's going on in the master. So if I update product, so now I've made a change which is dependent on this description.html file being here. But because I'm working in an isolated branch, that's not going to work. Let me commit my change. So now my feature branch and my master branch are slightly out of date from when I originally branched it. I've now got a dependency on description.html, but description.html doesn't exist within this branch. It only exists in the master, which has moved ahead in time, and we're now a couple of commits behind. So there's a few ways to get around this, but the best way is to do what we call rebasing the branch. So effectively, by rebasing the branch, we go back to the point where we initially branched off, and then we move that point forward to the current head of the master branch. And in doing so, we sort of replay all of the commits that have happened on the master branch and apply them to this branch. And then effectively, at the end of that process, it's as if we had branched off the master branch from the current head, not from the head that was 2-3 commits ago. And it's often a good idea to do this anyway with long-running feature branches to make sure that you catch any conflicts, any things that's going to give you problems down the road early on and get them fixed. So in order to do this, if we see at the moment, our latest commits are the adding of a new product, which we did in this branch, and the link that we've just added. So we want to take our existing branch and go and replay everything that's happened in master since we originally branched it and apply those changes to this branch. So we can do that by typing git and then rebase, and then the branch that we want to rebase on. So normally you'd rebase against the branch that you originally branched off. So in this case, master. So if I give it that, so what we've done, we've sort of gone back in time to where we originally branched off master, and we've now replayed all of the things that have happened on master in this branch. So the state of this branch now is as if we just branched it right now. And if I have a look at the log, here I can see I still have my addition of a new product and added link commits, which is what we did within this branch. But we can see here now that the commit that we made adding the description of the product, that commit now exists in our feature branch. And if I have a look here, don't forget I'm in new feature, we can now see that description.html exists within this branch as well. So now if we're happy with the work we've done within the new feature branch, we can of course merge that back. So now we can go to the master branch and we can merge all of the changes from our new feature branch back into the master. So while Git is very good at handling merges between different branches, there are times when you're going to run into conflicts where two different branches are trying to modify the same piece of data and Git can't determine which one should be correct and they conflict. And let's see an example of that. So if I create from the master branch, I create a new branch using git checkout-b and call that another feature. Within this another feature branch, I'm going to make a change. And I'm going to just make a change to this line here. And I'm going to commit that change. With git commit. And now I'm going to switch into my new feature branch, and in here I'm going to make a change to the same file, and I'm going to make a change to the same line here, and I'm going to commit that. So now let's go and check out master. I can use the git diff command to see the differences between master and other branches. So if I do a git diff on new feature, we can see that we've changed this wording here from complete to thorough. And I can do a git diff on another feature. And I've got a different change but on the exact same piece of code. Now first I'm going to do a git merge of my new feature. So this will pull in the changes from the new feature branch into the master. And that's fine, and I can see under HTML product that I have this wording now in master. Now the problem here is that both of these branches were branched off at the same point in the timeline. So the another feature branch doesn't have any record of this particular commit. So now when I try and merge in my another feature branch, we can see here that we weren't able to automatically merge this because the commit in the another feature branch is no longer compatible with what's going on the master branch. So there's no way for Git to know which is the correct version here. Now it's telling me the file name that has failed, and it's failed with a conflict. And in order to proceed, I need to edit this file, and sorting out merge conflicts can be a little bit manual, and you'll see for a minute. If I just edit the file, so we're already in HTML. If I just edit the file, here I can see that Git has added these lines here. And this tells me that currently right now in the head of the branch that I'm merging to, so master, that I have this content, and then separated by this tag here, it's now saying it's trying to merge in this line from the another feature branch, which has this data. And basically Git has no way to correlate these two together, so it's throwing it over to you to sort this out manually. So here if I decide that actually I want what's coming in from another feature, I want see a full description here, then I just literally edit this manually. So I want to get rid of that line, and that line, and that line, and that line, and leave the file in a state that I consider to have all of its conflicts resolved. And then I come out of that. And then if I do a git status, we can see the current status of product.html is that they've both been modified. I fixed that in our local working copy. So in order for that to take effect, I need to stage and commit that. So let's git add product.html to stage it. And if I do a git status again, I have a modification to product.html that's staged, and that contains the changes I made to resolve the conflict. And so I can commit that. And I can see because this is a merge that if I get thrown into an editor, it automatically gives me a default commit message, which I'm just going to accept. And there we are. So that's how we handle merge conflicts within Git. If you want to avoid too many merge conflicts, then if you do have long-running feature branches, then it's probably a good idea to try and keep them rebased against where you branch them off, so rebased against the master at regular intervals, and then you'll catch these things early and be able to fix them before you get a merge back into your master branch. So as we've already covered, at any time in the Git history, in the Git timeline, we can go back to a specific commit, and from that point we can branch off a sort of new pathway in the code and continue to work on that branch. What we can also do is create a snapshot as to how everything looks at that specific point in time on that branch. And we can do this using Git tags. So we'll often use tags for things like version numbers. So when we're ready to release code, we can take a snapshot at a specific version, and that's the code that will get released unmodified as it's immutable. The point about a tag, unlike a branch, is that once we've tagged a particular point in the timeline, that tag is immutable. So we don't go and modify and add further commits to a particular tag. It's a reference to a point in time. So in order to use tags, we have the git tag command. And I can see here git tag. If I do git tag with -L, it'll list all of the existing tags, which we don't have any yet. And then if I'm at the head of the master branch, I can now set a tag from this particular point in time. And I do that with git tag -A to add a new tag, and then give it a name. And that name could be something like a version number, so v 1.0. And then very much like when we did git commits, we get thrown into an editor as you can add a message to go with your tag creation. So we can give a message like released version 1.0. So if we look at git log now, we can see the latest commit up here at the head has also got this tag of v1.0. So right now the 1.0 tag is at the head of this repository. So now let's move the head by adding some more commits to the master branch. And I'm going to commit that. And I'm going to do yet another change. And commit that. So what I've done is add 2 new commits to the master branch. But these commits have been added since I tagged the 1.0 version of this repo. So if I do another git log, we can see now in the timeline, we can see at this point in time, at this hash reference, this is what we associated with the tag v1.0. And then since then, there have been these 2 new commits. And right now the head is sitting up here with this commit. So I can have a look at my readme.txt and see those changes. So we've seen before that we can use git checkout to both check out a specific branch or go to a specific point in time by using a git hash reference. What we can also do with git checkout is reference a specific tag and go back to that place in time. So again, if I go a git tag -l to list the available tags, we can see we have a v1.0. So I'm able to go git checkout v1.0. And then I'm in what's called this detached head state. So I'm not in a branch. I'm basically floating at a point in time back in the Git timeline at the point where I tagged this repo. And if I have a look at the log now, I can see that effectively the head that I'm working with is effectively back in time now when I added this commit and when I tagged this repo. And then if I look again at my readme.txt, I can see the changes I've made since the 1.0 tag was added are not present. So I could, if I wanted to, create a branch from this point. So this enables me to create a new branch based on the 1.0 code. And if I want to go back to the real head of my master branch, I just git checkout master again. And then if I look at git log, I can see now I can see the extra commits in my timeline and the additions to readme.txt. So that's the difference between branching and tagging. So when we create a branch in a specific point of time, we're creating a parallel pathway where we can add more code, we can add more content and add more commits. When we create a tag, we're just taking a snapshot of how everything looks at a particular point in time. And these snapshots are immutable, whereas branches will change and evolve over time. A snapshot is static and immutable. So we've so far just been working on a Git repository that's been checked out in our local environment. As well as making it easy to manage the files in your project and the revisions and the history, Git's also a really powerful tool for enabling collaboration between developers. And the way it achieves this is that we can have multiple copies of the same repository and they can all communicate with each other and push and pull data from each other. So we can have both Bob and Susan working on the same project. Susan can be making changes to one part of the code and Bob to the other part of the code, but they don't need to be both working physically in the same folder. If Susan makes a change to a Git repository on her local working environment, Bob can also be working with a copy of that repository and be able to pull that change from Susan's repository into his repository and keep the two in sync. This is the feature of Git which is probably the most powerful in terms of enabling collaboration between development teams. So unlike other version control systems, Git is a decentralized version control system. So it doesn't have the concept of a server and then clients, or a master and slaves, or parents and children. Instead, each repository can pull from other repositories. However, when we're working with other people in a team in a development workflow, we'll often have one Git repository that we delegate to be the master. So it's the authoritative repository where all the developers will push and pull from. That's not to say that those developers can't pull from between each other's repos, but most of the workflow will be through one central repo, which would essentially be your Git server. So you probably heard of products like GitLab or GitHub, which are fantastic tools, but you don't need all of that tooling in order to get a very basic Git server. All you need is a user and an SSH key. So in this section, we're going to look at setting up a very simple Git server and explaining how two developers can collaborate on the same repository. So what we're going to do now is create effectively a Git server. While Git is a distributed model, when you're working with other developers, you'll normally have one repository which is considered the master repo where everybody pushes and pulls from. So what we're going to do is create what's called a bare repository, and then we're going to push our local repository to that remote over SSH. So we've got a few things to do before we start. Let's first create a user called Git. So sudo user add. I want it to give it a home directory of /srv/git. So I use the -d flag and then served git. And I also want user add to create the home directory and set the permissions correctly. So create home. And then the name of the user that I want to create, which is going to be Git. So now I have my Git user. We're going to be creating a repository as that user, but the way we're going to interact with that repo is over SSH. So if you don't already have an SSH public key, now is a good time to create one. So I'm going to create mine here. So SSH keygen, and you want a standard RSA SSH key. So enter and enter and enter. And this should place your SSH key in your home directory under SSH. And what you're going to need to copy into the Git users configuration is your public key, which is this ID RSA public key. So you're going to want to now just copy this to your clipboard. I'm going to use xclip on the command line, but you could just edit it. So now I've got the public key in my clipboard. I'm now going to sudo and become the Git user, and we'll finish off the configuration there. So now I'm the Git user. I've only configured Bourne shell, so I'm just going to switch into a bash session. So now you'll see I'm not Craig anymore. I am the Git user, and I'm in the home directory of /srv/git. First thing I'm going to do is just configure the SSH. So I'm going to make a directory called .sh. And then I'm going to edit a file called authorized keys. So in this file, I'm going to place in the public key, which I previously copied to my clipboard. And then save that. And now importantly, I'm going to want to do a chmod 644. So change the mode to 644 on this file. And what this will do is make sure that it's not writable by any other user. So now the second thing I'm going to do now is go into my home directory of the Git user, so /srv/git. And I'm going to now make an empty directory in here and call this my project. And now within the my project folder, I'm going to initialize a Git repository. So we're going to use the git init command that we used last time. So in order to make a repository that we can push code to as well as pull, we need to make what's called a bare repository. So we do this with the git init command and followed by --bare, and this will initialize a bare empty repository here in /srv/git. So now we're going to exit out of the Git user, back into my own user. The first thing I want to check is that the SSH keys are working. So from my own user, I'm just going to SSH Git, which is the username that I created at localhost. And when I get prompted for the fingerprint, just type yes. So I'm able to log in to localhost using the Git username under SSH key authentication. So that's great. That works. So I'll exit out of that back to my own user. So now what we're going to do is we're going to go back into our project that we've been working on. So we're now going to set the empty bare repository that we created as the Git user as a remote repository, and then push this repo, all the contents of this repo, upstream to the Git repo. So to do this, we need to define what's called a remote. And I can have a look at existing remotes with git remote -v, and I can see we currently don't have a remote configured. So I can use the git remote command to add a new remote, and we give that a name. So git remote add. Typically we use the name origin if we're dealing with a default upstream repo. So the name will be origin, and then the address of where this repository is. So we're using SSH, so we give the username at the host name, which is localhost, and then colon. And then after the colon, we can give the name of a repo that is relative to the home directory of the Git user. So if you remember, we created under the home directory, we created a my_project directory, and that's where we initialized our empty bare repo. So I'm just going to type my project. So now when I type git remote -v, I can see I have this remote called origin, which is going to use SSH to interact with the repository that we created as the Git user. So there's three main ways that we work with Git remotes. One is to push, and one is to pull, and one is to fetch. So let's look at the first one, which is push, which is where we're going to take changes from our repository here and push those to a remote. In this case, the remote is an empty repository and it's bare. So we're going to push the master branch up to the remote repository. And because the remote is currently empty, we're just pushing the entire branch. So we're effectively going to be recreating our master branch up there on the remote. So we do that using the git push command. And the first argument to git push will be where we're pushing to. So we're pushing to the origin remote, and then what we're pushing, which is going to be the name of the branch, which is master. So git push origin master is going to take our local master branch and push that to the remote, in this case origin, which is the Git repository under the Git user. And there we go. So this is how we communicate with a Git server, so typically over SSH or HTTPS, in this case SSH. And now this remote that we've pushed to is going to become the authoritative repo. It's where all of our developers are going to be pushing and pulling code to and from. So now we're going to look at how two developers might work side by side on the same code base using Git, pushing and pulling to a remote Git server. So here I've split the window into two, and we'll see we have a directory here for Susan and a directory here for Bob. So both of these directories are empty. So we're going to assume that the top and bottom half of this window are two different developers. So currently Susan and Bob have empty directories here. What they're both going to need first is a copy of the upstream repo. And this is done by a process known as cloning. So once a developer knows the address of a remote Git repository, we can simply use the git clone command to go off and pull down that repo locally. So let's do git clone followed by the address of the repository, which is git at localhost colon my project. And then we can do the same for Bob. So now both Susan and Bob have an up-to-date working copy of the upstream My Project repo. So now we're going to see how Susan will make a small change to this code and push that change up to the remote. So let's go into HTML. Add some code here. And then Susan would stage and commit this code exactly like we did before. So we can git commit. So now we've committed this to our local copy of the repository. We can see here when we do a git status that we're being told that our branch is ahead of the origin master branch by one commit. So this is saying there are commits in our local copy which don't yet exist upstream. So if we do a git log here in Susan's version of the repo, we can see that the head of the master branch is here with the commits that we added Susan's changes. On Bob's local copy, however, we can see that the current head is at this commit, which is here on Susan. So Susan is currently one commit ahead of what everybody else. So Susan is currently one commit ahead of what's in the origin. So in order for Susan's changes to be made available on the upstream repository, we need to use the git push command again. So if I have a quick look at the remotes available, so git remote -v, we'll see that when we cloned this repo from the upstream, it automatically gave us this remote of origin with the address of where we cloned the repo from. So origin already exists. So as we did last time, we can do a git push origin and then the name of the branch that we want to push. So in this case, master, and there we go. So now the commits that Susan has added to her version of the master branch have now been pushed upstream. And if we have a look down here, Bob still won't have these changes. So in order for the copy of the repository that Bob has cloned to receive the commits from Susan, we need to, instead of pushing to the remote, we need to pull from it. So very similar to the git push, we can use git pull. By default, this will pull the same branch from the same origin it was cloned from, but it also takes the same arguments, and I like to be specific, so we say we want to pull from the origin remote, and the branch that we want to pull is master. And now I can see there's some changes to my index.html on Bob's working copy. And if I look at that, we can see that Susan's changes are now included in the working copy that Bob has. And if Bob does a git log here, we can now see that the working head in his cloned out copy is here, which is where we added Susan's changes. So we've covered all of the basic principles and basic commands that you need to run with Git. We've looked at setting up a repository, we've looked at working with files, we've looked at how branches work and how to merge those back, and we've looked at working with Git remotes. In the last section, we configured a very basic Git server using just a user and a SSH key. A more common approach, especially within the open source community, is to use GitHub. So GitHub is a service that sits on top of Git itself, and it's a tool that really enables teams to come together and collaborate on projects that are based around Git. The next course in this series is going to be diving into GitHub. So now you've got a good understanding of the principles of Git. The next step now is going to be GitHub. If you want to get notified when that course is released, then please do follow me, and I really hope to see you on the next one.